This video is Chapter 3, Section 7, Parallel and Perpendicular Lines. Two lines are parallel if they have the same exact slope, so if their slopes are equal. Two lines are perpendicular if their slopes are opposite reciprocals. So for example, if you had a line that had a slope of 3/4 and a line that had a slope of -4/3, these are opposites because one is negative and one is positive. And these are reciprocals because the numbers were switched. 3 was originally on the top and now it's on the bottom. So these are opposite reciprocals. Are the following parallel, perpendicular, or neither? And we need to explain. When looking at an equation, tell whether they are parallel, perpendicular, or neither. You can look at their slopes, so that's how we're going to be able to tell. If the equation is in the form y equals mx plus b, your m is your slope. So in this case right here, my m is 3. And in this case right here, my m is 1/3. 3 and 1/3 are not equal, and they are not opposite reciprocals. So these two lines would be neither parallel nor perpendicular. In the second example, right here, these are not in the form y equals mx plus b. So you need to convert them in that form before you identify whether their slopes are parallel, perpendicular, or neither. So in this equation right here, 2x plus 3y equals 6, you need to solve for y. So if I rewrite that here, so I can subtract 2x from both sides, and that will cancel these out. And I'm left with 3y equals 6 minus 2x. Then I can divide the 3 off both sides. And now I'm left with y equals, this would simplify down, 6 divided by 3 would be 2. This does not simplify down any further, so we would write it as 2 minus 2/3 x. So this equation would have a slope of -2/3. In the second equation, 4x plus 6y equals 19. Again, we could write that right down here. We have to put that into the slope-intercept form. So we could just subtract 4x from each side, which leaves us with 6y equals 19 minus 4x. Then I can divide this 6 off from both sides, and I'm left with y equals, this cannot reduce down, so we would just write it as 19/6 minus, this can reduce down, so we would say minus 2/3 x. So in the first equation, my slope was -2/3. And in the second equation, my slope is also negative 2/3. So these two lines would be parallel. So I just added a couple notes on here that these two would be parallel, again, because they are both negative 2/3 for their slope. And I also added on here that because these two slopes are not opposite reciprocals, they would be neither. They would not be parallel nor perpendicular, so we just put those as neither. Other things to look at in order to find slopes are graphs. So when you have a graph and you are trying to identify slope, you could count your rise over run. So this blue graph here, I can create a little staircase from this point to this point. So if we draw that in, we go from this point to this point. One rise up to two. I rise up to and over one. So up to and over one. So the blue graph has a slope of 2 over 1. So we'll just write over here, blue has a slope of 2 over 1. And I can do the same thing with the red graph. Make my staircase from point to point. I rise up 3 and over 1. Up 3 and over 1. So for our red line, we have a slope of 3 over 1. These are not the same, and they are not opposite reciprocals. So these lines are neither parallel nor perpendicular. In the second graph right here, if we do the same, we can look at the blue line and the red line. The blue line, if I count my slope, I can go up 1 and over 2. But since I went to the left 2, the blue line has a negative slope. So for blue, we could write it as negative 1 over 2, because once again we went up 1 and then over 2. The red one, I make my staircase here. I can go up 4 and over 2. So we go up 4 and over 2. So for red, we would say that it would equal 4 over 2, and that can be simplified down, so we could just say that it was 2 for that one. So if the blue line slope is negative 1/2 and the red line slope is 2, they are opposites because one is positive and one is negative, and they are reciprocals. 2 by itself has a denominator of 1. So if 2 over 1, if we flip that, is 1 over 2. So these lines would be considered perpendicular. The last example is using the point-slope formula or form of an equation to write parallel and perpendicular equations. The formula for point slope is y minus y1 equals m times x minus x1. So this equation says write an equation parallel and perpendicular to the line y equals 1/3 x minus 2 that goes through the point 3, 1. This point that you're given is your x1 and y1. Notice there's an x1 and a y1 that you're given and an x1 and a y1 in the formula. So the only thing that we need to figure out to complete this formula is our m, which is our slope. So if we use this original equation, everything is based off our original slope. So if I need to find a parallel slope to 1/3, it needs to be the same slope. So for our parallel slope, we would just keep it the same as our original slope. And for our perpendicular slope, it has to be the opposite of 1/3 and the reciprocal of 1/3, which would be -3/1. When you write your equation, you're going to set it up just like this. You are going to place your new m for your slope and your x1, y1 respectively into your new formula. So your parallel equation is going to be y minus 1, because we're just using our values from up here, so that's where I got the 1, equals, we're doing a parallel, so we're going to say 1/3 for our slope, x minus 3, right from that x1. And for our perpendicular, we would say y minus 1 equals -3/1 times x minus 3. Here's one example for you to try out and see if you can figure out if these would be parallel, perpendicular, or neither. So go ahead and see if you can figure that out now. So for this equation, this set of equations, these would be neither, because this one has 0 slope, this one has a slope of 3. So since the slopes are not opposite or reciprocals, they're not equal, so it would be neither. I gave you another example down here and said if we did have, however, if we would have changed this equation just slightly and said 2y minus 6x equals 12, then those slopes would have been the same, and that would have made those two lines parallel. Here's another example for you. Here's your equations. Are these parallel, perpendicular, or neither? See if you can see what your answer for those would be. So in this first set, you have a slope of -5 and a slope of 5. Those are not equal, and they are not reciprocals. So those would not be either. They would not be parallel nor perpendicular, so we would classify those as neither. Here's another scenario. If we had y equals -x minus 7 and y minus x equals 20, those would be perpendicular. So you can copy down this example for future reference as well. Here's our last example. I need you to write a parallel and perpendicular line to y equals -5x plus 2 through the point -4, 2. So go ahead and try that now. So using point slope, this is what we should have come up with. For our parallel, it should look like this. And for our perpendicular in point slope, this is what we should have ended up with. Go ahead and copy those down in your notes so you will have those for future reference as well.